Welcome to an episode on the Estelle Ingenuity podcast. I'm Stephen Estelle, engineer, CEO, and founder of Estelle Ingenuity. In our episodes, we dive into different experiences from people who specialize in technology, entrepreneurship, and other necessary elements that will help you reach your full potential in these fields. We focus in on innovative devices that will be changing our society, stories from entrepreneurs and how they maneuver through the business landscape, and how these new technologies are being used in businesses to bring value to the world. From these stories, if you are inspired to develop your own inventions and prototypes, and you want to see your innovative ideas flourish, reach out to us at estelleingenuity.com for your prototyping needs, so together we can begin creating the new devices of the future. With that being said, enjoy the show. Follow and subscribe to Estelle Ingenuity Podcast and relish the wisdom from the topic you hear today. So then now let's talk haptics and let's get into some of these haptic ideas. And I want to first start with one question that was in the presentation. You talked about it was like mid-air haptics, and I was trying to wrap my brain around what is I guess to first start. So haptic devices send out a sensation for individuals who might not know haptic devices. And then in your lab, you have different kinds of haptic devices. Can you go over different kinds of haptic devices you
Yes.
play with, and then why they're being utilized?
Yes. So haptic technologies, basically, it corresponds to technologies which try to stimulate either your sense of efforts. So basically, these are force feedback technologies. So
like a vibrating motor.
Or it's not vibrating motor. In this case, it would be like force feedback joysticks or force feedback wheels in video games.
Got you.
Which would, for instance, simulate resistance and force at the level of your joystick or your wheel.
Yeah.
By means of actuators, motors, which are exerting forces on your body. So this is it's more like force and effort sensations. So this is one kind of haptic technology. And then there's the second category, which correspond to tactile technologies, which try to stimulate the envelope of your body, your skin.
Right.
And all the different sensors that are in your skin. So we're not talking here about the muscles and the tendons, which correspond to force feedback technologies, but here to your mechanoreceptors, the tactile mechanoreceptors embedded in your skin. And this corresponds, for instance, to technologies stimulating thermal sensations, vibrations at the level of the skin, texture and relief, friction or sliding sensation at the level of your skin, slight contact or pressure on your skin. And for every of these tactile percept correspond often one dedicated technology. That's the complexity of this technology. It means that if you want to have all the sensations,
that's where it gets,
then you have to bring all these pieces together, right? So this is becoming, a mess in terms of mechanical assembly, right?
Yeah.
So you are a mechanical engineer, so you know that. So you have to make. So either you want to build the ultimate haptic displays, which would assemble all these components and then have like huge amount of actuators, or you have to make choices.
Yeah, you got to choose.
And you have to choose. So usually in the video game market, for instance, people have chosen the vibratory feedback. And so you have, for instance, in your gamepad, you have like one vibrator. Two vibrators, right? And sometimes you have a force feedback joysticks. That's another one.
Yeah, I think the PlayStation 5 may have like a force feedback trigger. Yeah. Something like that.
For instance.
I don't have a PlayStation.
So that's a nice challenge with haptics, is that from the very beginning that you will not be able to fulfill it.
And that's the puzzle of science. But tell me, why are haptics important? Why have you looked into haptics as part of your labs, and why are you implementing them?
So I really started with haptics, actually. That was my PhD topic in 1998.
Okay.
So bringing haptics progressively to VR. And it's quite natural, actually. The objective of virtual reality is to recreate another alternative reality, as realistic as possible, as immersive as possible, meaning that the illusion must be fulfilled by means of these sensory stimulations. So you start usually with visuals, then you add audios, that's the easy part, and then what's next, right? So the next part is usually to try to bring some more tangible sensations, physical sensations in the virtual world, to make it feel more real. Because usually you miss this, right? You touch a virtual table and then you penetrate inside this virtual table and then the illusion is fading, right? So you quite rapidly, even starting from the 80s or 90s, people started to work on haptic technologies in virtual reality. So it's a pretty ancient field, actually.
I actually didn't know that. I thought VR was like... I knew it was like... It didn't come out of nowhere, but I didn't know exactly when it started. I thought it was... I mean, it just started becoming more consumable, I guess.
Oh, yeah, no. It started... Usually, I mean, in general, with technologies, you can find roots.
Right.
I mean decades ago. So in VR, the starting moment, there is not an official starting date, right? But I mean, you find some pioneers already in the 1950s or 60s, and then you have this, for instance, one of the most famous godfather of virtual reality is Ivan Sunderland, who built this with his colleagues, of course, this first HMD, which is very similar in principles, in concepts, and even in design of the components to the ones that you are seeing today commercialized a bit everywhere. So these first HMDs, here it was even an augmented reality HMDs, where these first proof of concepts were already existing in the 60s.
So where do you see...
So 60 years ago. Where
do you see this going in the next 80 years? As like a researcher who really dives deep into this? Because I'm more of a consumer.
Yeah, first of all, I'm very confident in the fact that this is a field which is going to, I mean, still question us for decades in front of us. I mean, I'm pretty sure about this. Just talking about haptics, as I said, it's unless we discover a very fascinating technologies which enables to blur completely your haptic modality in a way that you believe that you're touching all the dimensions of an object, we still have an open path in front of us to invent haptic technologies. But that's one part of the puzzle, and the puzzle is like huge. So in terms of research and technologies, the challenge is so huge and so pluridisciplinary that we have years and years of research in front of us.
I'm interested. So I'm curious about your thought on this. I forgot the exact name of it, but it was, yes.
No, just to add something about where we are going, right?
Yeah.
Maybe, so it's a difficult question. And researchers don't like this question because it's like you have to become a medium or, like a magician with your crystal ball.
Yeah.
So we don't like this question, and we try to avoid and skip it, right?
Okay.
But still, if I'm trying to address it, I would say that what we're still observing today is that these technologies are progressively becoming more hybrid and integrating more and more sophisticated technologies, multi-modal systems, embarking more and more sensors and actuators. So what we are observing is somehow a trend in an increased complexity and hybridization. How do you say it in English?
Yeah.
I mean, adding more and more sensing and actuations in the systems, right?
Right.
Probably bringing also artificial intelligence in the systems to, for instance, being more aware about the user actions, intentions, physiological states, mental states,
right,
and adapting the interaction to the user in a more, let's say, intelligent way also. So that's probably the future of this technology. That's one possible future of this technology.
Yeah, I'm hoping that the VR and the AR field becomes like I'm seeing now, like AI is starting to become more publicly used, and now everybody is. I got it on my phone, I'm using it for work, and I'm hoping that with VR and AR, like for myself, the closest I've used when it came to that field was more so Pokemon Go when that was trending a few years back. And then I played maybe 1 or 2 VR games on like the Meta Quest that they have from Facebook. But I'm hoping that the VR, AR field becomes more like a laptop or a smartphone. It's just, if you don't use it, you just, like, people are more confused if you're not using it than using it. And one piece of technology or just an idea that I'm curious about, if this can be implemented in this, was, I don't remember the exact name or the video. I would have to find it, but there was a use of some like magnetic powder, some chemical or something, and then because it's like magnetized, you're able to kind of like control how it, I guess, forms and moves. And then there was another one that was using sound as well to make shapes. But I'll be curious if, let's say you had a magnetic glove with this magnetic powder and then sending out magnetic, I guess, very specific magnetic patterns to maybe help deliver these different sensations. For like, if you had a full magnet that was preventing you from moving down or pulling you, you can attract it. I don't know, and I'm sure that's very like technical because you have to be very precise in things. But I'll be curious if we use more of a finer material and then using something like that. I'll be curious if that can help us be more exact, and then you can customize different forces in there.
Yeah, maybe. So I'm not definitely an expert on this technology, but there are probably 2 ways to apprehend this problem of this complexity and this too high complexity. So one is to try to find the proper breakthrough technologies, like the one that you're suggesting, and testing it and see how far it can go in the simulation of this reality. And the other one is to find alternative paths and to play with perception and to find, for instance, the minimal haptic actuation which maximize the illusion at the end, at the level of the percept of the person, right? So this is, for instance, what we did with pseudo-haptics, which is a technique that we invented like 20 years ago, and we are still continuing to work on it because it's really a fascinating topic too. It's with very, very limited hardware. Sometimes you can produce very powerful and strong haptic illusions. And sometimes you can play with these tricks, perceptual tricks, instead of trying to invent a very sophisticated hardware. And let me take one example to illustrate pseudo-haptics. The challenge of, for instance, feeling the texture of an image, right? So you pass your mouse cursor on an image and you want to feel the relief and the texture of the image on screen, right? Very complicated to achieve. So there are lots of surface haptics at the moment on this, working on this topic, using piezo or other actuation technologies to change the friction at the level of the interaction between your surface and your finger to feel the texture and the relief of the image, right? So what we invented 20 years ago is a very simple trick. Imagine you manipulate a mouse and your cursor is on the image passing over this image, and imagine that there are different, for instance, stones on this image, and when the cursor is passing over a stone, you would simply artificially reduce the speed of the cursor when it's arriving on the stone until the top of it, and then you are artificially accelerating the speed or increasing the speed when it's descending.
So it's like a visual,
right?
Got it.
So it's a purely visual trick. You are playing with the gain of the cursor, right? The gain of the mouse. But by just doing this, like decreasing the speed, accelerating the speed, what we observed like 20 years ago is that people would definitely associate this to a bump on the image, right? On the opposite, if you accelerate and decrease the speed, you would associate this with a hole or with a hollow.
Right, because you're going down.
And it's like 99% statistically observed with everybody, right? So with this very simple trick, which costs nothing more.
Nothing than just a little toggle on the screen.
Just this. Well, you can simulate very nicely texture effect.
Interesting. I remember actually my colleague, he showed me actually this kind of a software, and I was using it. And I remember there was one where it was like, it was very rough. It was like zigzag, and I was moving the mouse across, and it made me actually feel uncomfortable.
Yeah.
Because I can't explain it, but I felt like oh, this, like, even though nothing, it was no vibration, it was just a mouse, okay. But the sensation of a mouse like kind of like wobbling across was very like cringy,
because you have some kind of connection with your cursor.
Yeah, there's like oh, just go straight. Yeah, it was kind of cringy at that point.
Yeah. So we worked a lot on this topic, and it's very, very convincing, and it's already fulfilling a lot of practical needs in many VR applications where you need to simulate some physical sensation at one moment.
Yeah.
Like when you are touching a wall, pressing a button or something. If you have like this specific need, for instance, in a training scenario, in a medical palpation scenario, sometimes the needs in a pedagogical way are very simple, but beneficial for the trainer and the trainee. And that's what we did with some, for instance, partners in the education field. We identified some needs in virtual trainers where you don't necessarily need to provide a very sophisticated haptic device for this.
Yeah.
Using such kind of visual tricks is enough to fool the perception and somehow transfer this pedagogical knowledge. So what we believe somehow is that with all these technologies, there is of course a technology-driven approach or technology-pushing approach, which sometimes makes sense because you need to push these technologies on many aspects. But in a more practical way, often what you need to do is to consider the needs, better analyze what with your, for instance, with your end users or with your partners, what really is their objective in terms of pedagogy or training. And then you can refine your scenarios and maybe identify what is the proper haptic needs here, or let's say technological needs here. And in many cases, we found that we can address a lot of these applications with very simple with very simple technologies, which are very fulfilling in the end for the end users.
That's really good. So I want to then talk about, this is kind of like it's a small change or a small switch, but I was talking to another colleague of mine, and she was talking about like, oh yeah, I use the software that you created, to get it correct, the Open Vibe correct. And I was talking to her about it. She was like really excited, like, oh man, like Anatole, you made the software that I was working on, things like that. She was like really excited about it. And I wanted to get some cool information about what brought up the idea of your software when you're thinking about opening Open Vibe. And if I remember, it's like a computer brain interface kind of a software.
Yeah.
What's the story behind that?
Yeah, it's a complete shift in my research agenda and research path, which happened in 2003, so 20 years ago. So I was really working on core VR technologies, haptics, as we just talked about it. And then I received a CV from over the sea from a potential postdoc candidate who told me about electroencephalography, EEG.
Yeah.
And at this moment started to, it was already a long story, by the way, so it's dating from the 70s.
Okay.
It's real EEG analysis and brain-computer interface research started a long time ago. I was not aware about it, so this guy contacted me and told me that maybe there's a connection between VR and EEG and brain analysis, and I started to dream about it and said, oh, that's a very original path, right? Mixing virtual reality technologies with brain interfaces and neural interface. That could be a very interesting connection.
Right.
And I was super excited about it. I just discovered that this was actually not new at all.
Okay, you're late. Yeah.
But that's usual, classical in research, and you have to be very humble.
Yeah.
But we started and we built a very nice research activity around this. It was not completely new, but it was pretty original still, right?
I get you.
There are not many labs working on this very complex combination of two difficult challenging technologies, neural interfaces and virtual reality technology, especially 20 years ago. Imagine 20 years ago. So we started there, and we grew a lot actually. So and what we noticed is that there were not many tools existing for newcomers like us to start actually on this topic of brain-computer interface. If you wanted to start a research activity on this topic, then you had to more or less start from scratch. That was very painful because you have to master neurophysiology, signal processing, and very complex signal processing, EEG data. It's very complex. Okay. So we started a project in France where we proposed that we would build an open source software for beginners on this topic.
That's really good.
And that's the beginning of it. Right? We wanted to start, but we didn't know how to start. So we said, okay, we will start by building a software which enables people like us to start to work on this topic without all the problems that we're facing right now.
Right. No, that's a really good solution because, like you said, if the introduction curve was so hard, this kind of just made it, and then made it more accessible for people to use it. No, that's really awesome.
And that's a super great success because OpenVibe is now one of the most used software in the field.
Oh,
so
nice.
It's one of the top 2, top 3 software used on the topic in the world.
Oh, okay. Are you guys still like continuing developing it and what are some new ideas?
First of all, because all our research, and not only the research of my lab, but all the INRIA teams in France, most of them are using this software. So we have to continue to maintain it because all our research activity is based on it. But not only ours, but the research activity of many, many other groups. So we are maintaining it for our research, but also as our contribution to the community. Right?
That's good. So you are split between your research and working on this software, or is it more given? So
personally, I'm not now supporting the software actively by coding it. Right?
Yeah.
So. And since the very beginning, I worked with very good engineers who designed, extended, and supported the software during all these years. We started in 2009, so it's been 14 years since we've been continuously maintaining and supporting the community with this software.
Right.
And the good news is that starting next month, we are going to we have secured a full-time permanent engineering position on this software, meaning that INRIA will be able to, on a very long run, to maintain this software for everybody.
That's good.
Yeah.
So for all the software users out there, you know that it's going to be continually updated.
OpenVibe will be there for a long time.
That's awesome. No, that's good to hear because when I heard my colleague talking about it, she was very excited.
And just to explain to the listeners what it is, it's a software which enables to very rapidly design applications based on brain-computer interfaces. So if you want to, for instance, start to control a robot or play a video game using your brain activity, this software enables to somehow to build the entire software pipeline between the acquisition to the communication with the external application, for instance. And there are lots of it's been designed in a way that it's not for people who want to, for instance, to program in C++. There is a graphical user interface, so it's supposed to be user friendly. Of course, it can be better, but
I got you.
At least it's open source. It's usable. It's open source for anybody who wants to work on this project.
That's awesome. I think the fact that people know that there is open source technology out there that they can download like immediately will potentially inspire people to even just try. And I think that's actually going to, especially the next generation that's like, oh, maybe I might be an engineer. And they'll go through that situation where like, okay, what inspiration is there? Then whether if it's a parent or maybe, oh, well, let me try this. I'm curious. So I don't know. That's interesting. I'm sure somebody out there is probably just going to download it and just, hey, let's see what I can do.
Yeah. We are personally. I'm like super happy when I'm typing on YouTube, made with OpenVibe.
Okay.
All these videos coming from all the parts of the world. On different topics. It can be an artistic performance. It can be the control of a robot. It can be whatever. I'm like super happy to see that I mean, this tool has been used, for instance, for things that we couldn't foresee at all.
Right. No, that's a good, like, that's gotta be a good feeling to know that an invention you made is being utilized. Yeah. I feel like that's a goal of mine of like, whenever I'm inventing ideas, I want to one day see somebody else who I have no idea using it and being creative with that idea. I feel like that's like an engineer's like dream. And that's really good.
Yeah.
All right, so then let me end the podcast with the question that I always talk to many people. So the question I want to ask you is that as humans are moving forward with technology and science and entrepreneurship, what is one thing that you are hoping for or looking forward to for the human race?
Oh.
Anything that could deal with technology, or maybe you are hoping that, I don't know, one day we will, I don't know, land on Mars, anything.
No, it's very easy for me because
go for it.
It's been like months that we're talking about metaverses.
Yeah.
And it's a big buzzword, but it's also a lot of money which is invested.
Yeah, I've heard. Yeah.
From a lot of people. And what I hope is that we will make good choices here. I really hope this.
Good choices and like
for the benefits of everyone. So I really think that this technology can become a nightmare in terms of carbon impact, especially.
I agree.
And this is very, very critical at this moment. The decisions that we are going to take in the next years are very important for this technology to become, for me, like a good human invention or a nightmare. So what I hope right now is that people are going to, collectively and individually and at the level of companies are going to take good decisions. That's what I hope.
That's a good thing to think about. And then we just gotta hope that just faith in humanity, and that with good science, people know how to take that tool and use it, hopefully for the betterment of humans, and not just humans, but the earth and everything that gets affected, of course. So, awesome. So before we end, is there anything that you would like to send out? Would you like to say if people want to get in contact with you, any way of anything like that?
Oh, okay. Well, sure. I mean,
go for it.
No, first of all, I just want to say thank you to you actually for this invitation.
You're welcome. Yeah.
As I said, it's my first. I think it's my first interview in English. So what I hope now is that my English was understandable.
It was good.
If you liked it, and if you understood, you can contact me. And if you didn't understand, then you can also contact me.
Nice. So I'll make sure to get your information. I'll plug it into the comments or something. But is there an email or maybe some location of who you are that you might want people to know or anything like that?
I think my email is really available easily over the internet.
So I'll make sure that's there.
It's very easy and people can contact me, of course.
Okay.
I'm not always answering fast to emails.
That's okay.
But okay, I'll try.
Okay. Well, again, this has been a pleasurable podcast. So thank you again.
Thank you very much, Stefan.
That was the end of an episode of the Estelle Ingenuity podcast. Hope you learned something new and innovative and were left inspired to go create and invent new ideas for the betterment of society. Make sure to follow and subscribe to the Estelle Ingenuity podcast on Spotify, Apple Podcasts, and YouTube for more stories and experiences from people in the field and to hear about new up-and-coming technology. Thank you for listening, and see you in the next podcast episode.